Welcome, GMBG. How are you today?
I'm fine, Louis. How are you?
Good, thank you. And for our listeners and viewers, welcome to another demo day with Astar. I'll be your host, Luis, and here asking the important questions to BG from SubQuery. Our guest today, we're going to give us a demonstration about the product and a good overview. BG, the most important question for us and the viewers is going to be, what's your favorite Pokemon and Japanese food?
Wow. All right.
Yes.
I only know Pikachu. I only know Pikachu and I love sushi for sure. Definitely best food
Th-
all
Those
time.
are good choices. You're safe now. The whole team will love you.
Um,
And at least you knew one Pokemon out of all of them. Um, but in all seriousness, thanks again for joining us today. Our developers and our builder community for sure appreciate the time you've given us and to give us this good breakdown of SubQuery. So to begin, we would like to understand more what SubQuery is, it does, and experience that you may have on the team and in the space in general.
all right. So yeah, I serve as a representative of SubQuery and its sister project called On Finality in developer relations activities. SubQuery is going to be the project that I'll be mostly talking about today. This is a indexing SDK. Actually, this is indexing end-to-end solution, and it's giving exposure to data by allowing to access the historical data, any kind of historical data that is happening on chain. So that's what we're doing.
Awesome. And how long have you been in the space for?
It's been ready for 3 years, I think. It's all started on Polkadot. It's all started with substrate chains, and yeah, Aster was one of the first to be supported. And we've also been working, obviously, on the frontier support, the compatibility layer, the substrate per chain. But yeah, we're supporting ZK VM now, and having some exciting things to show you during this workshop.
And what other ecosystems are you now spread out to? Over the 3 years, I imagine you've grown quite a bit.
Yeah, so currently it's more than 200 chains supported, if I'm not mistaken. Mentioning the specific blockchain, the supported blockchain architectures, it's obviously Substrate, Polkadot, it's Cosmos, EVM, Algorand, Nia, and some more exciting architectures are coming.
Wow, that's exciting. And BG, before we get into the gist of it, could you give us a little breakdown of what we're going to see in the following demo?
Yeah. I was doing some background checks, and I know that James was doing already like 2 years ago a fireside chat with A-Star. It was, I mean, most of basic things were covered then. So I decided to not repeat James and talk about new features and more sophisticated and exciting features, specifically multi-chain indexing and aggregation of multi-chain data. And I'm going to be supporting it with a demo, obviously.
Sweet, thank you. You could tell James that we totally forgot about him, and so we're just focused on you. You're our superstar now.
All right.
Jokes aside, let's get into it then. BG, thanks again. I'll let you take it away.
Thanks a lot, Lewis.
Mhm.
So I've prepared some slides for you. Are they already live? All right. So yeah, essentially, this workshop is going to be split into two parts. It's going to be a theoretical introductory part to SubQuery, just going to be supporting all the words that I've said with visuals, and just do a brief solution overview, and then it's a demo time. So essentially, as already said, SubQuery is an end-to-end indexing solution. So the core product is obviously the SDK, And with the SubQuery SDK, it's possible to get exposure to historical on-chain data, whether you want to have access to historical data like happening as part of the events of smart contracts, transactions, of blocks, and much more. And you really need indexes if you want to be powering your applications with custom data. So let's take the most basic use case, which is the displaying of all the transactions done by a certain user within the wallet. So technically, it's not really a convenient way to be querying the RPC nodes like directly and trying to look in the older blocks, the specific like entities that are helping you to understand that this transaction was happening by that user. So instead, what would probably make sense is to make some kind of a wrapper around around the blockchain, so that it's only consisting the data you need, and only then querying this this API, this wrapper. And obviously, it's going to be much faster than trying to get data directly from nodes, and probably simpler because it's a usual interface. So essentially, the interface is GraphQL, and there were several rationales behind like GraphQL being the interface powering all those things. Obviously, the biggest advantages are the ability to connect the entities and essentially, leverage like all the technical capabilities of this framework. So it all starts with an indexer SDK. So it's completely local deployment friendly. It's Docker friendly. So that means that obviously you're able to verify that it's indexing and serving exactly the data that is needed. So essentially, you're able to verify everything locally, and then make the decisions about deploying it somewhere. So since it's Docker friendly, you can self-host it. The second option for deployment would be the managed services. It's a centralized cloud developed for SubQuery projects. It's really easy to set up, and it's that's the simplest way to essentially deploy your project and not be worried about its robustness and uptime. And the third option would be the decentralized marketplace, a SubQuery network. That's a decentralized solution. That's essentially a network of indexers. That's not going to be the main topic of today's workshop. Today's workshop is more about SDK, but I'm happy to answer some questions, or even if needed, we can plan this second part specific about the network, because it deserves some time to be explained. So why SubQuery? First of all, it's a completely open source solution. It's really easy to set up, given the fact that it's Docker friendly, and self-hosting friendly as well. It's really simple to configure, because at the end of the day, you only need to configure 3 types of files, which are data schema, manifest file, and handler files. So I'm going to be explaining the purpose of each of them during the demo, just to support my words with code. It's really customizable. So every SubQuery indexer is a TypeScript project, and obviously you're getting the flexibility, you're getting a freedom of doing whatever you want within the execution of indexing. So not only you can work with on-chain data, but at the same time you you're able to query the external services like centralized APIs and similar things. It's really fast. It's feature reach. I mean, just to name a few, it's aggregation, type safety, um, automatic type generation, and much more. It's real time, so you can connect to the indexer via WebSockets and obtain data on the fly, essentially. It is multi-chain, so from a single indexer project, you're able to connect to multiple heterogeneous networks like zkVM and A-star and substrate A-star, not the frontier necessarily, and aggregate this data within this multi-chain indexes. So it might be useful for those who are developing the apps that are cross-chain, where you're interested in, when you're having the transactions executed cross chains that you're interested in obtaining data from the both sides of the execution, essentially. It's really flexible and compatible with several ecosystems, including substrate-based chains, EVM-based chains, Cosmos, and so on. It's really easy to get started with, but obviously you'll have some prerequisites if you want to be running your SubQuery project locally. You'll have to have Node.js installed. You'll need Docker for a convenient running of all the services that are of all the components of the indexing, because not only you need to index data, you also need to store it somewhere and provide an interface to it. So we're going to be every Docker project essentially running all those three components up. And SubQuery CLI. This is used for the SubQuery indexing, scaffolding, and project initiation, together with type gens and essentially all the main steps when it comes to the development of SubQuery indexing. So there's going to be 3 files that are configured as part of every SubQuery indexer. It's a schema file, manifest file, and the mappings files or handlers. So it's I guess it's time for demo. Are we having any questions on this small theoretical part that I can really answer?
We had a question about API cost. I don't know if you want to go into that or at least direct the viewers to where they can find out more.
Yeah, there are several options. So as I said, you can self-host. You can self-host on your own machine, and it's coming with its own pricing. The second option will be to host it on the managed services, which is a centralized cloud provided by SubQuery. It's having several tiers, obviously, and including the free tier. The details could be found on the official website, subquery.network. The third option, as I said, will be published to the decentralized network, and it's having its own economics, and it's having its own, even means of payment. So all the info is on the website. That's subquery.network.
Perfect. I'll tag that into the comments. And yeah, let's get going with the demo. Thanks.
All right. So so the demo that I'm going to be showing to you is going to be a merged version of 2 template indexes for A-star that are already in place. So we're just going to be merging them by doing the multi-chain indexing. So we're going to be indexing both A-star zkVM and A-star frontier compatible per tag layer. And we're going to be fetching data simultaneously from both of those networks. It's going to be the transfers and approvals of USDC tokens on each network, and then we're going to be making the aggregations on top of it. So essentially, we'll be able to calculate like how many of those transfers happened, and we'll be able to group them by some parameters like network, and essentially doing aggregations, so multi-chain aggregations. So this is the first project. I'm going to be taking it as it is and remove this substrate part. And the second project is this one. So again, those are the projects that are already in place that could be accessed via and scaffolded via a SubQuery CLI. So yeah, you can get the same code. I'm also having the project code already developed, so we won't be doing the live coding. I'm just going to be explaining the code. But if you want to be starting from ground up and building your project from scratch, I really recommend you looking into the documentation of SubQuery. So this is the best page to start with. It's having all the steps to install in it and launch your project. So now moving to the code. All right. Yeah, should be visible now. So as I previously mentioned, there are three essential types of files to be configured. The first one is a schema. So schema is essentially an API specification, an interface of query for the queries that will be acceptable by this API. So since we're interested in USC token transfers, we're able to make those as the separate entities and populate each of them with data with certain properties, including ID, value, the sender, the receiver, the contract address, and the network, because we would want to essentially understand like on which network was it happening, and we want to identify each network and make for instance the same aggregations and based on those networks. So that's the first file. As you can see, as a network, we're having a enum. It's either L1 EVM, which is frontier compatibility layer of A*, or L2 ZK VM, which is a separate network. So the second type of file are manifest file. In our case, since we're having a multi-chain project, we're going to be having three of them. We're going to be having one main one, which is essentially connecting two of the manifest files that we want to be using for indexing. So that's a manifest file for ZK VM chain. You can see all the configurations here: name, description, all the settings, chain ID, the RPC, where we're going to be fetching data from. You can also see the start block. You can see the token address and the specific handlers that we're going to be using. So in case of EVM chains, there are three handlers available. It's a block handler, transaction handler, and finally a log handler. We're going to be handling the transactions, the approved transactions, and transfer events. So how is it supposed to work? So essentially a manifest file is an instruction for the indexer where you want to be fetching the data from. So in case of this log handler, for instance, we're telling the indexer, hey, you should only be indexing the logs from this specific smart contract, starting from this block, from this chain, and so that topics match transfer, so the transfer event itself. And once the indexer finds the event that matches those filters and configuration, it's going to be taking it and passing as a parameter to the handler. We're going to be giving a unique name for a handler. In this specific case, it's going to be called handle L2ZK EVM log. And those handlers are TypeScript functions that are being described as part of a third type of the files that we'll be configuring, which are mappings files or handlers. So essentially, we use schema to specify what entities will be available and what will be the interface of the API. We use manifest file to give the instructions to the indexer what raw data essentially one needs to fetch from blockchain. And we use the mapping files to process those like primitives from blockchain in the form of transactions and events, process them somehow, decode them, and save them as part of the entities that we've been previously setting up in the schema file. Just to give you an example, so we had a handle L2ZKVM log. It is only handling those specific events and passes those events as an argument to a handle L2ZKVM log function. We can find this function here. So here it is, handle ZKVM log. Let's cross-check. Yeah, that's having the exact name. So as you can see, it's accepting the log of type transfer log. And what are we doing next? Next, in order for us to essentially be able to set the different origins, the networks that this transaction occurred, we are interested in passing the network alongside the log itself. So in this specific case, we're accepting this log, and without any processing, we're just passing it to another function as a second argument together with a hard-coded network name. So it's being passed to handle EVM log. This is the function that's doing the further processing. So it's accepting network log. As you can see, first we're checking whether the arguments and events are sufficient, and then we go ahead and decode the log and populating the entity, the ERC20 token entity with the decoded data. So we're taking the transaction hash from log for ID. We're accessing from the arguments of the events, and we just eventually saving it asynchronously. And that's it. So yeah, at this stage, we're good to go. What we did so far, we've been able to tell the indexer what exactly we want to make queryable. We also told the indexer what needs to be fetched, and we also told the indexer how would one need to process the fetched primitives and save those. And now we're able to run the indexer. So I've done it in advance, and I've done it with a turned on aggregation feature, which may be a little bit unsafe to use, especially if you're having a open endpoint for your indexer, just because it might require some computational power to make the aggregation, since originally data is stored atomically. So if you think of the relational databases, we're having a single row for a single transfer. And by using aggregations, we're essentially aggregating. If you know SQL, it's like, so in this specific case, it's like a group by function. So yeah, and I also prepared a simple query to do. Essentially, we're asking the indexer to return us the grouped aggregates, grouping by network. We want to be calculate for each network that are in place. Again, it's only 2 in our case. We want to be displaying the exact amount of the transferred that were indexed so far, and the sum of value of all those transfers that happened within a specific network. So if I press the play button now, I'm going to be waiting for the execution, and we can see the response here. So it's really easy to read. For L1 EVM for Frontier, so far we're having 2,000 transfers indexed, and this is the overall value of transfers. And for L2, we're having only 500 transfers indexed, and this is the sum. This is the sum. This is the sum of value, essentially. So what are the benefits here? As you can see, you're getting all those numbers pre-calculated. So if you're developing a application and want to be powering your app with some kind of a statistical data, there's no need for you to make the calculations within your code. So instead, you can configure an indexer, you can make it multi-chain, you can enable aggregates, and essentially, once it's done, you would be able to power the statistics page, for instance, right away. And it's a very convenient thing to do. So as you can see, I'm having it launched from the managed services, a centralized cloud of SubQuery. But obviously, you can self-host it, and you can publish it also to a decentralized network. All of them are having the same possible features, including multi-chain and aggregation. So there are no limitations within any deployment option for those features. All right. So yeah, once a couple of words about network. So SubQuery network is growing. Not only it's powering the indexers, it is also giving the possibility to run your own RPCs. That way, making the stack truly decentralized. That's another topic. That's a rabbit hole. It's a very complex system with its own set of factors. Happy to talk about it. A little bit later. The best place to start with the SDK, with the understanding of the network, is a centralized documentation hub, a SubQuery Academy accessed by academy.subquery.network. And the best place to start with, the best place to ask the questions for support is Discord. Yeah, on that part, I think I'm good. Happy to answer any questions if there are any.
Thank you so much, BG. That was a good demonstration too. Just thinking out loud, the multi-chain aspect of it and indexing and grabbing data from this multitude of chains is amazing, simply because I really do think the future will be multi-chain, right? I think a lot of chains will exist, even on Astar too. We have two, a ZKVM and our L1, and yeah, so I'm just impressed by the way technology keeps growing, especially I think some of us have been in the space for a while, and it just keeps just surprising me. So thanks again, BG. I really enjoy it. No questions from the community so far, but I do want to grab your perspective about where do you see, SubQuery in the next 5 or so years, regarding, indexing and data transmissions and storage as well.
All right, so there's a big announcement coming soon. I cannot shed the light on it, but stay tuned. It's going to be mostly about this SubQuery network. Speaking of SDKs and essentially the tools that are giving the exposure to historical data, I think it's only going to be growing when it comes to the amount of features. It's only going to be faster. The nodes, the RPC nodes, would probably be modified to work this historical data because there's no blockchain that is shrinking in size, unfortunately or fortunately. So it's just going to be more data to handle, and it's just going to be more sophisticated methods to handle this data. And I guess that's a continuous thing, never ending.
It does sound never ending, right? Especially as everything becomes more digitized, or everything is already digitized for the most part. Yeah. Great. No, thank you, BG. And that announcement, I know you can't give us details, but we'll just wait for it. Better yet, we're excited here at SI. We know we have a long-standing relationship with SubQuery on Finality as well for RPC endpoints. So we're excited for this, and for the listeners and viewers too. You could see how SubQuery has been part of our ecosystem for quite a while, even participating in our public forum, making requests there. So feel free to jump into their Discord, or if you have questions, jump into ours as well. They're a friend, longtime friend, and we could direct you to where you need to find your answers. BG, thanks again. Any last comments from you on behalf of the team?
Thanks a lot, Louis. It was a pleasure to have this workshop. Yeah, excited to collaborate more. Excited to help the developers. Excited to support, and yeah, looking forward to the updates on that side as well.
Awesome. Thank you so much, BG. Have a wonderful day, and viewers, thanks again for tuning in. And have a great day.
Thanks. Cheers.
Cheers. Bye-bye.